Hi guys, this video requires just a little bit of introduction before you watch it. This is a job that came in a couple of weeks ago. I had a call from a local hotel who said they had a problem with the sound system in the pool bar. That's pool as in swimming, not as pool as in shooting, yeah? So I went out to have a look. They have two passive speakers outside of the bar and sort of in the outdoors, and then they have an amplifier, 1500 watt RMS amplifier, quite a heavy one, behind the DJ booth. But they don't use it as a DJ. This is background music really. So this is just the ambient background music around the pool where people are sitting, relaxing in the sun or swimming. It's not a club or a disco. Yeah, it's not played loud. And the problem they had, one speaker, only the horn was working, no bass at all, and the other speaker was working at low volumes, but as soon as you turned it up to any reasonable volume, it started to distort badly. So the great thing about this video, I want to show you something now. This is a very good example of a situation where you go out to a job, so you have a complete working or not working system. And from that, you break the problem down to find out first which items are faulty, and then which parts of those items are faulty, and then gradually down to component level to exactly what is causing the fault in that part of the circuit or on that item. So I hope you enjoy this, guys. If you watch this one through, you're going to learn a lot about how that process works, and it'll help you a lot in your repair work. If you really don't have the attention span to watch 1 hour odd videos, then I have to say I'm not sure repair work is for you. When you're doing repair work like this, it takes a lot of time and concentration. If you think I've waffled in this video, apart from this bit at the beginning, let me know. But I think this whole video all the way through is showing you exactly what you need to know at each step. Anyway, I'll see you all soon at the end, and enjoy it, guys. Hi guys, welcome to another Learn Electronics Repair video. I have a pair of these speakers in the workshop. These are used at a local hotel in the pool bar, so they kind of like sit just outside. They're exposed to the elements somewhat, and they were working until the lockdown. The place was shut for 18 months, like most of these places were, and then they don't work very well. So I have two of these. One I think has got no bass at all, maybe just the horn is working, and the other one, as soon as you turn the volume up to anything reasonable, it starts to distort badly. So I'm not sure which is which, but these are not amplified speakers, they're not active speakers, they're just passive speakers. So I'm interested to see whether or not we can actually fix the problems on one or the other, or whether we actually just need to replace the speaker drivers. So let's get the front grille off this, and then let's have a look to see what we have inside it. This one, the bass speaker seems okay. Normally if like the coil is burnt out, when you push on it like this, you get a scrunching noise. But this isn't doing that, so that's probably a good speaker, unless it's open circuit. And if it's open circuit, we might be able to fix it. So that's that one. I think the best thing to do with this is to connect it to an amplifier, and let's see what it's actually doing. This is an amplifier I use for testing speakers like this. It's actually a mono amplifier. It does have two speaker connections, but they're both on the same channel. When you connect the left and right, the same audio effectively mixes it together. So it's actually a mono amplifier. It's about, well, it says 300 watts, but it's not 300 watts exactly. But it's got a fair heat sink, and it's actually quite a reasonably powered amplifier. It's certainly good enough for testing speakers like this. Okay, so you can probably hear this one only has the horn speaker working. So let's get the woofer out and let's see if it's faulty, see what's wrong with it, yeah? I've unscrewed the speaker. You can see it's just effectively held on with a couple of push terminals. The black and red goes to the negative, the red goes to the positive. So we can disconnect that. In the bottom of the speaker cabinet now, you can see the crossover down here. So the fact we have no sound coming out of the bass speaker, the woofer, could be a problem on the crossover, or it could be a problem with the speaker itself. It's more likely to be a problem with the speaker itself, but not always, yeah. I mean, anything can happen, yeah. Anything can happen in the next half hour. As they say, yeah. I'm going to use that my catchphrase for this channel. Anything can happen in the next half hour. Bonus points for anybody who knows where that came from. Comments below. Anything can happen in the next half hour. Yeah. I don't know if you. I'll probably Google that. It'll probably tell me where it came from, but still. I'll trust you guys not to cheat you. And I'm sure somebody does know where that comes from. Okay. Turn the meter on. So this should read 4 ohms, 8 ohms, depends on the impedance of the speaker, but it won't be exact, so it might read 6 on a 4 ohm speaker. What it shouldn't do is read open circuit. Yeah, the meter's working. So this is open circuit. So we have from here 2 wires which effectively go down into the speaker cone itself down in there. I can probably get onto this end of the wires, but I expect it'll be the same here. Just get into them. Yeah, open circuit. So effectively this is a dead speaker, but we could possibly resurrect it and call it Lazarus. Yeah. That comes from, well, being biblical, but it comes from the Commodore Amiga. It had like a facility where it could like recover a floppy disk, and if it could recover the disk, it renamed it Lazarus. So this is where we need to be a bit brutal now. We need to get the cover off here. This is the dust cover. So this is the actual speaker cone, and this is just a dust cover. So we need to get this off to get to the coil, and the way to do it is to come as close as possible to where it joins to the cone. Put your knife in. You need something sharp at an angle, like so. Yeah, and you'll find that you can get into it somewhere near to here. Yeah, and now what we need to do is actually cut around this as close as we possibly can to like the seal. This is basically glue, so we need to go in here like this and try and keep close and come in at an angle like this, and hopefully you won't hit the actual voice coil. But you know, at this point it's faulty, it's dead, so there's not a lot you can do here to make it worse. Well, really, yeah. This is actually coming into the glue part of it. And we can glue this back in, so if we manage to repair this, then we'll glue the cover back on. And it'll be as good as new. Yeah, that's the plan. I have to find my actual Stanley knife. This is working well. It allows me to get in very close to here. I don't have the actual thickness of the Stanley knife handle in the way, basically. Okay, let's go. I repaired somewhat of these. In fact, I actually made a video very similar to this a year or more ago, and those 2 speakers are still working. Okay, so that is off, and now we can see the actual format of the voice coil, and this one is dead. If I get the camera and zoom down, you'll see what the problem is with this. So somebody's been overdriving this speaker. You can see effectively there's one of the wires which is turned to charcoal, and here is the other one, and these connect to the end of the voice coil. So this one is actually still connected to, or it was, the end of the winding. So we can have a look. I mean, normally when you've done this, the whole former effectively warps and starts to catch against the magnet down there. This is strange, it's not done that. Let's see if we can get to the end of this. So this is the end of our wire, and I'm sure you can see on there is effectively the wire coming in, and that joins onto here. So this is the actual end of the voice coil itself. The other one, the wire is here, and the end of the voice coil is down in here somewhere amongst all this charcoal. It's actually there, and strangely enough it's still actually attached. Yeah, it's still attached to there. Although I say this is dead, we might be able to get this to work actually. I'm concerned that this is warped here, but it hasn't warped further down. So the first question is, we'll just clean all the dust out. Is there any continuity on the coil itself? So let me clean the dust out, and then we can get our test meter and see whether we have any continuity from here, this bit of wire here, to this one here. Yeah, we can do this with the meter on resistance range, but I actually have a better way. So I'll just see if I can see any sort of continuity. Yeah, there's something there. I probably have something there, but the way I normally do this is to use an analog multimeter, and I'll show you why that is better. This is my analog ProSkit MT2017. I've had it probably since 2017. I had it before then, so that's not the year it was made. And this has a bleeper mode on it, and with this one, I'm sure you can hear it bleeping. But the good thing about this is it sends enough AC current into the speaker to make the speaker sound as well if we get a good connection. And it's not doing, I can hear the meter, but normally I would hear sound out of the speaker as well, and I don't seem to do. Even though the speaker's free moving, I don't actually get any sound out of it. Let's see what the resistance is, and then I'm going to try and solder these wires on anyway and just see what it does, but I think this is not going to work. Let's go into the continuity mode on my other meter. Okay, let's try this. I hope that was going to be more decisive. I'll show you on the horn speaker what that does. So there we have it. Now what sort of resistance am I seeing on this? Okay, we're reading about 6 ohms. That's what you'd expect it to read. So let's see if we can solder our wires back onto the coil. So to do this I need to straighten it up a little bit, probably. A bit of flux, and then we'll come in with this wire and we'll try and solder the two together. This can be a bit fiddly, but if we do manage to solder it, we can put a little bit of resin on araldite to hold it in place, or some other sort of adhesive. So let's go and see if we can tin the wire. I've definitely tinned that. A little bit of flux is always going to help, so let's get a little bit of flux on this. Okay, the usual flux, a little bit on the wire, and a bit on the other end. Then again we'll try and tin the two wires. Okay, so we have this one and we have the other one. And then it's a matter of trying to bend the two wires that they're running in line with each other and soldering it back on. So let's see. I mean, what we don't want to do is snap the wire off. That's the problem with this. But I think I can get probably a connection like so. Okay, so you can see now that that wire is attached to the end of the voice coil. We can bend it over down a little bit. I can put a bit of glue on that, which will help to keep it in place, but it's definitely soldered on there. In fact, I might just try and get a little bit more solder. Of course, at this point it will fall off and I'll have to start again, but let's see if we can just get a bit more solder onto this. And what did I tell you? Know when to leave things alone, yeah. Important lesson. See if that's got it. Again, we'll soon know by moving this. Yeah. That's got it. That actually looks like a better soldered joint to me on that one. And it's the same with the other side. Has that got it? Let's see. Yeah, you can see it waggling around the whole thing, yeah. So that's got it. So we should now, across the terminals, be able to measure continuity, well, about 6 ohms. So let's have a look, and this will tell us if we got a good connection or not. Yeah, you can see where I am. It's almost in shot. So what do we read across the speaker? No, it's not. It's not good. It's reading the resistance, but it's high. So let me just see which end is the problem if I can. Go from the input. Let's have a look at this one. I think this is probably soldered. I have continuity to there. I have continuity to there, so that one is soldered. Do we have continuity to the other one? It's actually come off again. I do have, so it's this end that isn't soldered. So let's have another go at soldering this one back on if we can. Okay. See if that's got it, yeah? See if that's got it. Okay, across the speaker terminals. No, that's shorting the two together. Yes. So I'm now across the speaker terminals. It's actually reading 0. I would have thought it read about 4 ohms, 2 ohms, okay. So we have a connection across the terminals. Let's see if this speaker is actually working now. Okay, well, it's still not working, to be honest, not well. There's very little bass. If I turn it up, we get that, yeah. I have a quick look at the crossover, just as a problem with the crossover, but I think the speaker is just no good, and I'm not surprised considering the amount of damage there, where it's obviously got very hot. The easiest way to do this then is to take the speaker out, attach it directly to the amplifier, and then see what happens. Yeah. and that's what happens. So it's very distorted. I'll just try a good speaker just to prove there isn't a problem with any of the other equipment. Okay, so this is a good speaker. I mean, we're not going to get much bass out of it because it's not in an enclosure, but that's working, whereas the other one was just horribly distorting. I've taken a photograph of the damage on this one, so I'm just gluing the dust cover back in place. I'll put this back in the speaker. He can have this one. Well, I'll tell him how much it's going to cost for a new speaker, and it's up to him, really. So that's that one. There's nothing much else we can do with it. So we'll put this on one side, let the glue set in. Let's have a look at the other one. Here's the other one. Again, this doesn't make a scrunching noise, so that seems okay. Let's connect this one up and see what we get out of it. As I recall, at the bar, this was playing okay till you get any reasonable amount of volume, and it was distorting horribly. So let's try it. Well, this made a little click when I switched it on, which is what you would expect to hear. Let's try some music again on this one and see how this one actually sounds. Yeah, I think sometimes always not what it seems. I mean, this speaker sounded okay at moderate volumes at the hotel. As soon as you turned it up, it was distorting horribly. But this is not like making a scrunching noise, and a bad speaker would. So it seems very likely now the amplifier is at fault. This may explain what has burnt out at the other speaker. If possible, it's presenting a DC voltage on the output. That would burn a speaker out quite easily. So I'll give the guys a call, ask if I can pick up the amplifier, and then we'll be back and we'll see what happens effectively in the next part of this video. Okay guys, another day, but the same job continued. So this is the amplifier. It's quite a hefty one, 1500 watts, 750 watts per channel. It feels heavy enough for that to actually be true. So I can't really see it's likely they've used this to overdrive the speakers. I mean, you can damage speakers with an amplifier below the rated wattage of the speaker by seriously driving it into clip. So effectively the top and bottom of the sine wave is flattened out. It becomes a DC voltage. But A, it sounds horrible, and B, this came out of a pool bar. So this is the bar at the side of the pool where they do snacks and beers and cocktails and all the sort of things you want on a holiday. And so this is playing basically the ambient music around the pool. It's not blasting music out loud. So, I mean, I accept it takes a fair bit of power when you're outdoors to get, you know, a reasonable volume. But this is not, it's not run loud. Yeah, so I really don't know what's caused that speaker coil to burn up like that. One possibility, as I mentioned in the video earlier, is that this is putting a DC output voltage on one side. Now, I do know the other side distorts badly once you get any amount of volume into it. So let's have a quick look and see first if the amplifier is putting a DC voltage on the output. Checking the amplifier for DC voltage on the output of the channels is quite easy. So we take our meter in volts range and we have a look. So this channel is reading very close to 0 actually. Let's make sure I got a good connection in there. Yeah, 0.023. And this one, 0.388, almost 0.39. So we definitely have a voltage on this one. It's not particularly high, but ideally here the voltage should really be close to 0. I mean, at 0.4 of a volt with 4 ohms, what's the current flowing? I equals V over R, 0.4 divided by 4, about 100 milliamps. And then the wattage would be 0.1 times 0.4, which is about 0.04, about 40 milliwatts. So it's a very low wattage, but it's possible the amplifier would behave differently when we connect a load on here. I mean, I could just attach my speakers and have a loop. Alternatively, I could just connect like a 4 ohm resistor and have a loop, and that might be the best bet because I don't want to go damaging any speakers. I mean, I don't mind if I damage a resistor. The question is, do we have any resistors in the 4 to 8 ohm range to test with? I have a couple of 4.7 ohm 10 watt resistors. I'm sure we can use these to test this. I'll have to just solder some longer wires on so I can connect them to the speaker terminals. I mean, if I end up burning up a resistor, it's a lot less painful than burning up a speaker. So I'll put a 4.7 ohm load on both sides, and let's just check again to see if we have a DC output voltage. Okay, I've put a couple of resistors on there. Again, you can see the current limiter. I've actually got it set to limit this time. If the bulbs come on a lot brighter and stays on a lot brighter, that suggests there's a fair bit of current going through the resistor and more voltage. But it's gone quite dim, so we're now switched on. Let's have a look. Well, we have practically no voltage across that one. Just go to the other one, and we have practically no voltage across that one, so that seems fine to me. So I'm going to connect my speakers onto the amplifier and let's see if it's working. Okay guys, that seems to be working. I can just turn one channel up, then the other channel. So both channels are working. And I would say possibly a little bit distorted, but I'll turn the input levels, I'll turn the amplifier down a bit actually. Just try this, so give it a bit more. Yeah. That channel sounds pretty. And this one's distorted. Can you hear it? This one's okay. This one's distorted. Let's switch that off and let's swap the speakers around just to make sure there's not a problem with my speaker. So we'll put them the other way. Okay, I've swapped the speakers over. So again, we'll go with this one, which is obviously on that speaker now. We'll just take it back to where it was a little bit. I think that's probably okay now. Let's go back here. Now go do one. Yeah, so basically that one's distorted, yeah, and that one isn't. So yeah, that's this speaker on this channel, and that's the bad one. Yeah, so we've obviously got some sort of problem with this amplifier. Let's open it up and have a look. So here's our amplifier. We have basically two channels identical, left and right. I think this is the one that was distorted on this side. I'll have to just double check. And we have a power supply board down here. At the front of the amplifier is effectively the input, the preamplifier. On here we have the volume controls and the LEDs. So that's what we have there. I've noticed, and I'll probably have to zoom down to show you straight away, a couple of things. This capacitor here seems to be bad. doesn't look good, and that is on the channel which has a problem from what I can see. And there's a resistor here that might have a problem as well. So this just from a visual check really, which is obviously a good thing to do. Let's zoom down and have a look. This is the capacitor I spotted. It's clearly bulged. That's a flat one on the other channel. This is on the bad channel, so straight away we're going to have to replace that one. And down here, I just want to check this resistor. It's like, I don't know if I've got a break in it or something happened. These are 2.2k resistors, so we can just check to make sure these both read okay as well. I'll just get the test meter. Okay, we're there on ohms range, you can see that. Let's have a quick look at these two resistors. So there's a capacitor charging up, obviously. I'll just measure the two, and I'm guessing they'll probably read about the same. Yeah, the same sort of reading going on there. I don't think there's a problem with the resistor. I have two on the other channel anyway. Yeah, same sort of thing happening there, so we can say that that's probably okay. I'll still have to take this circuit board out just to change this capacitor. We may as well change that first because it's obviously gone, and then we can just double check to see which channel actually has the distorted sound. Just before I remove this board, you should just be a bit cautious of these large capacitors. So these are 63 volt 10,000 microfarad, the big capacitors. Each channel is probably plus or minus 55 volts or something like that, and it's worth just checking to be sure there's no high voltage in these capacitors before we remove the board. The fact the amplifier was kind of running suggests there probably isn't. Easiest way to check is on the plus and minus rails. If you have here, going to the channel, these will come from the capacitor, so we can just have a quick look. Yeah, there's nothing there. Let's get into the other one. Yeah, there's nothing there, so they read okay. And I can check on the other channel as well to be certain. Better safe than sorry. But it really should read okay. Yeah, nothing there. Very slight voltage there. Okay, let's get this out. This is just a matter of disconnecting lots of wires. Make sure you note which one goes where before you take it apart, otherwise you're not going to put it back together right. I've mostly got this apart now. All the connectors are off, the board's loose. I'll try and remove these once I get the PCB lifted up. But down in the middle here, it's been held down, and I'm certain that is the bridge rectifier. And I had a look underneath. There's no bolt holding it in place from the other side, so I suspect I've probably got to unsolder these 4 wires to actually lift the board off. So let's see if we can do that with a bit of solder braid. It seems the most likely way I'm going to get this apart, so we can just get in first with some leaded solder. I'll just clean the joints up, and then we'll try a bit of braid. And it looks like these legs kind of like push backwards, if you know what I mean, rather than going through the board, but we'll see. I mean, I could be wrong, but I can't see any other way to free up that bridge rectifier. Let's try some solder braid and see where this gets us. So we'll just start with this one. It's the easiest one to get to. Let's have a look at what we've got. Yeah, can you see there's like a slot here, so we should now be able to push the leg of the bridge rectifier towards me. Let's see if we can do it. Yeah, I don't know if you can see I don't know how clearly you can see in there, guys, but that is basically free, and I need to do the same with the other ones as well. So let's get a bit of light down there, you might be able to see it a bit better. Yeah, can you see I'm moving the leg? You can see it now, I'm sure. So I'll clean the rest of them off and then we'll get this board out. Okay, I've unsoldered that and the PCB now lifts out. I can find out afterwards if I had to do it that way. Yes, I did, I think. So it's just a matter now of unplugging these. They can be quite tight, and then we can get this board out and replace this capacitor. And I have the PCB out. It's quite clear this one is domed, it's bad. I can just unsolder it from here. There was a black wire, heavy black wire soldered to here. It was bolted to the back of the amplifier. It was hard to get to where the bolt was, so it was easy to unsolder it. But I just made a note there, and I took photos on my mobile phone so I know which wire goes where. I don't trust them to sort of lie in position. You know, by the time you've got this thing out, everything will have moved around a bit. I put a blue mark on this one and a matching blue mark on the connector, and the rest are on the photograph. So we'll just take this capacitor out, which I'm guessing is the same as this. This looks like a symmetrical sort of circuit. It's the plus and minus 15 volt supply, and it's quite possible that a bad capacitor here could cause distortion, because this supply will be supplying the preamplifier, the front panel of the main amplifier. And if there's something wrong with the 15 volt, I mean, you would expect, in all honesty, the problem to occur on both channels, but it's got to be changed anyway. If it's not causing our problem, it's going to cause another problem sooner or later. So let's take this out. Okay, I've removed our capacitor, just used a bit of braid, pulled it out and cleaned the holes. It's a 25 volt 470 microfarad capacitor. Let's have a quick look to see what it actually reads. I have the ESR meter. This is not a low ESR capacitor. It's not on a high frequency rail. This being a linear power supply with a large transformer, but it should still read a reasonable ESR, and the capacitor should read as high or higher than the rated value. Let's see what we've got. Well, the ESR is pretty bad at 1.47, even for a non-low ESR capacitor. That's not good. Okay, here's the capacitance meter on the 2000 microfarad range. Some people ask why I use a capacitance meter rather than the multimeter, which has a capacitance range, and the simple reason is it just does it better. It reads capacitances instantly, where I put it on a multimeter and it'll take some time to read it. We can check that. So it's reading 120, so it's reading bad. Yeah. Let me show you how that reads on my multimeter as well, just to sort of explain why I do it that way. Apart from the fact I have a capacitance meter, so I need to justify the €15 or so it cost me to buy it. Okay, let's go on here. I've gone too far. Go again. Capacitance. Yeah, capacitance. Need to clean the screen a little bit. Okay, let's see how it reads on here. It's obviously a bad capacitor reading 120. Let's have a look. Wrong leads. Let me try with the correct leads. Yeah, I realised that was the wrong lead. Okay, again, positive, negative. Always read them the right polarity. It doesn't do anything for ages, yeah, and then eventually it reads it. That's why I use a capacitance meter. Okay, guys. I'm going to fit this one. This is a salvage 470 mic, 35 volts. You can see the ESR is like much better. Yeah, much better. And we can just check the capacitance as well. And I'm sure this will read at least 470. Yeah, 495. I've replaced the capacitor. It's a bit bigger, but there's plenty of room in here. You can see that's the bridge rectifier. It's bolted down onto a stud which you can't get to from the other side of the case anyway, so as far as I can see, the only way to actually get to this was to do what I did, which was to unsolder where the pins are from the bridge rectifier. I'll put it back together. Let's see if A, it's fixed the problem, and B, if it hasn't fixed it, which channel is actually the bad one. Well, that's one channel, and it's not distorting now. And then the other channel, and that's still distorted. Yeah, that one's okay. and that one is not okay. So the capacitor did not fix the problem. I know now this is the channel that's distorting. It's this one. So we have, if we just look, and I'll just zoom the camera out a little bit. There we go. So we have basically, you can see ground plus and minus power coming into the amplifier here, and the same on this channel. The audio comes in the front here. There's a little screened cable here, so that's feeding the audio in on both. That comes from the little board at the back, which has some capacitors and things down there. And then we have the board with the volume control, which attaches to the amplifier on this cable. The other one goes back to the board back there, and the same with this side on this cable. So what I can do, I think, first is take these zip ties off and swap these two wires over. So what I'm basically doing is I'm connecting the front panel, the opposite channel. So we can take this off here. We can disconnect the connection from the amplifier and see if it will reach. I mean, if it won't reach, I might be able to persuade it to reach. If it won't reach, I can always unscrew this front panel. But as luck would have it, it almost reaches. If I untangle it down here, I can probably do this actually. So I can probably, yeah, I think I can get this to reach here, and this one here to go to the side. So the idea is basically I'm swapping this lot over, and I want to see whether I still have the distortion on the same channel. This will very quickly figure out where the fault is. If this doesn't solve the problem, I can hopefully swap the input wires, or for that matter I might just swap the two channels over altogether from one side to the other to see if the fault stays on the same side. But let's see if this will work first. So can I get this to reach into here? You know what, it won't. It's so close. Maybe it will like this. Yeah, it just fitted. That just fitted. Does this one fit on the other side? No, it doesn't. But what I can do now is see if this one is still distorting when I'm feeding it through here. Yeah, through this volume control on this side, feeding it through here. So let's try that. The other one, I probably don't even need to worry about connecting or disconnecting it. I can just leave that off there, maybe. If I can get it to fit, I would prefer to. Let's see. Maybe let's go under here. Will it reach our... No, that one was not going to reach. Again, down to the bottom. Will it just reach? Do you know, actually, it might just reach. Let me see. I get this connected to go into here. Be nice if I can. Yeah, it looks like I actually can. Just by routing it a slightly different way. Yeah, that's in there. So I've now swapped the two over. I want to see if the same channel has the problem. So this channel's still okay, and this one is still distorted, so the fault is still on here. Again, another thing I can try is to take the different audio input, the one from this channel, onto this channel. And this really has swapped everything plugged onto this channel, so I'm coming through the different inputs, through the different controls on the front. And let's again see if this channel distorts now. Yeah, that's still distorting the same. So we're now feeding from a different input. We've tried from the different connections here, it makes no difference. So we can say with certainty the fault is on this amplifier module. We can put this back where it came from, and let's have a look to see if we can figure out what's wrong with our amplifier. Okay, let's measure some voltages first then. So we'll switch on, we'll just check a few basic things. So this is the main power to the amplifier module. This is the positive power rail. That's 100 volts on positive. That's 100 negative. I'm guessing these capacitors must be in series because these are 63 volt capacitors. Other channel power minus 100, plus 100. This I think is the 15 volt supply where we found the bad capacitor. Let's have a look. We have a minus 14.6 and we have a plus 14.6. So if you couldn't see it, 14.6 minus 14.6. That looks okay. This is the connection to the front panel. We've swapped that over. We have another connection which goes down here. This is probably some sort of voltage supply. Well, that's 26. That's 26. And that reads 0. What's on the other side? We have the same sort of connector here. This goes down towards the back. Let's see what we have on here. Is it the same as the other channel? Well, that looks like it was 0. Yeah, 26.36. And the other side, yeah, 26.36. So we've got the same sort of power rails on both amplifiers. But this one is distorted. It's not a power supply issue from what I can see. So I need to figure out where we can actually check probably the oscilloscope on this. Let's see if we can find somewhere where the distortion starts. So normally we would start from the input to the amplifier and work our way through to see where the distortion is introduced, because it can be introduced early on in the amplifier circuit and then effectively just amplified by the output. I doubt we've got bad output devices. They normally go short, and we obviously don't have a short because, well, first of all the fuses don't blow, and then secondly the protection circuit clicks off, you know, it's happy. So what I need to do is try and find out what's driving into the output stage, and then maybe check there with the oscilloscope to see if we have distortion at that point or not. And I think probably the easiest way is just to take this amplifier module out actually and get it on the bench. Let's have a look at this amplifier module. I can actually plug it in if I just put it at the side of the amplifier like so. We have basically black as ground, and we have the white as a minus 100 volts roughly, and red as plus 100 volts roughly. This cable is the audio signal coming in. Then we have this one. So this goes to the volume control on the front of the panel of the amplifier, and also the LEDs. If we move that over there, that will fit. So the only one left is this. Now this is the 26 volt supply. Goes to here. Well, what I can do is I have just a scrap cable off something. It's worth salvaging these sort of cables off things, so that will plug in there. If I sort of cut this off, I can solder onto a pin header and plug it into there, and then effectively I have the 26 volts as well. I have to cut it off because there's only 2 wires coming down this end. I need, well, technically actually I probably need 2, because 2 of the wires are both 26 volts, so the one's ground. But anyway, it's not a problem. We can take this off here, and I'm sure we then have the 3 wires to solder onto here. One of them might just be a sleeve of ground, but it's still a wire. Yeah, it's a wire. So I'll solder a little pin header on here, and then we're in a position to test the amplifier module. And to be quite honest, we can do the same with the other one, with a good one. So if we want to compare the two to find out what difference we have and where, we can easily do that. That's the idea. Okay, so let me just sort this out, and then we can think about how we're going to diagnose the fault. I've soldered that on there. So we can see that normally this would go this way round into the socket, and this goes in. Let's just put it in this way round. So the one that's the white would go to this end. This is slightly uneven due to the soldering, but yeah, white, black, red, so they're in the same order. So that's the 26 volts. This is just a fan, so we don't need to worry about that one. We can now get to the PCB quite easily while we're trying to work. So let's see if we can diagnose this. We know the problem isn't in the front panel or on the input because we've swapped them around already, so it is on here somewhere. I'm going to try something now that should very quickly give us a good idea where the problem is on this amplifier module. So let me just connect some stuff up and then I'll show you what I have in mind. Okay, so I have some sounds connected. What I was going to try and do was turn the volume up on the mixer. So I've got the volume on the amplifier on the front connected to half, and I want to try and turn up the sound on the mixer until it distorts. But no, it's distorted at all levels. The idea was it's not going to work. That's distorting, yeah? The idea I had, but which isn't going to work, was this. I was going to turn up the volume on the mixer till it starts distorting. I was then going to turn down the volume on the front of the amplifier and see if it stops distorting again. The idea being that if it stops distorting when I turn this down, the problem is on the other side of the volume control, if you see what I mean. But it's distorted at all levels. You can hear it there, yeah. We might have to just use a signal generator and put a sine wave in. But let's just get the thermal camera. Let's have a quick look if that tells us anything. Okay, so I can see that down here, 2 resistors, I think they are. The other side of this coil. There's 2 resistors here glowing hot, but they're not like really hot, if you see what I mean. Let's have a look on the other channel. Yeah, we get the same on the other channel. That's the good channel. So I'm sure you can see it down there. The same thing lighting up. So that's not any problem. And they're not really hot. They're like, you know, they're over 50 degrees. They're running quite warm. So 2 resistors there. But as I say, if I look at the other channel, I don't have a speaker attached to this one, but they're still pretty hot. Okay guys, I'll just explain what I was trying to do there, and I think it did actually prove something. So I was feeding in an audio signal, which we know comes in via these 2 wires from the back panel. The volume controls connect here and here. So my idea was that if I set the volume controls on the amplifier to the midpoint, turn up the volume on the mixer until this channel starts to distort, and then turn down the volume on the amplifier on the same channel, I wanted to know if it stopped distorting. So if it sort of stopped once I turned this down with the same input level, I'm thinking it's something after the volume control, however it's wired in, I'm not quite sure. And I'm not totally certain at all, because there's actually 2 lots of wires here. One that goes to the amplifier and one that disappears down over there somewhere. And the same on the other channel. No, the other channel just has the one set to here. So that's what I was trying to prove. But in the way I proved something, because what I found is that this channel distorts really. It's all volume levels. It's just more noticeable the louder you turn it up. So what we'll try and do now is to trace it through. I'll use some music. If this isn't giving me anything clear on the oscilloscope, I'm going to use the oscilloscope to look at the waveform. I might just inject an audio, like a sine wave at 1 kHz. Now, being a cheapskate, although I have a signal generator, I think I'll have a look on the internet. I'm pretty sure I can find a free audio signal generator I can run on my PC and just feed the sine wave in via the mixer. You know, for free basically. But let's have a look first. So we've just got a bit of music. I've turned both amplifier modules on the sides and put them back in the case. Now all the cables reach and I can probe them both. I can do this on this amplifier because the heat sinks themselves were bolted directly to the metalwork. So if you look at the output transistors, there are mica washers under the transistors which isolate them from the heat sinks. You might not always be able to do this because in some cases the heatsink is at the same voltage as the collector of the transistors on one side or the other, the plus or minus voltage rail. So it depends on the design, but in this, clearly the heatsinks are bolted directly to the chassis, so I can do that. And I've had it switched on and it's fine. So let's get the oscilloscope, let's get the camera where you can see it. And let's see if we can see where the distortion is starting from. I think it's somewhere near the input because of the thing I tried with the volume controls. The first thing I see, I don't have any schematics for this. There are schematics online for this, but I can't find any free sites that have them. I can find some pay sites that have the schematics. And I have no objection to paying for schematics. If they get me into a position where I can fix the job, believe me, the cost of the schematic will go on the bill, yeah? And I've got the schematic for future. But in this case, and again, I know some of you guys perhaps disagree with that, and we think we shouldn't be paying for schematics, seeing as the person who posted it no doubt is not the right solder anyway. Let's try without. If we still can't get anywhere, we'll have to get some schematics. I'm interested in these resistors are getting hot on both. I have a suspicion that they are probably dropping from the plus and minus 100 to a lower voltage rail, which is supplying this lot of circuitry. And I'd be interested to see what voltage is on either end of these. This lot seemed a bit cooler than this lot, but I had no speaker attached to this one at the time. Now I've attached both speakers, so we can look at that. Another thing I see right at the input is an operational amplifier, this chip on both, which is marked 5522D. 5532D. I can't easily get it. Yeah, it's 5532D. I can't zoom down, so I can't get it far enough on the bench for you to be able to see close up, unfortunately, guys. But I'll also get the data sheet for this, and we can have a look at there are dual operational amplifiers. So each op amp has an output. There's two outputs on each of these. And again, I'm interested to see what's coming out of those chips on both channels. Are they different? First of all, let's just measure the voltages on these resistors. So no audio coming in. Let's just measure the voltage. We can have another quick look with the thermal camera again. And let's see if those voltage rails are the same or there's something wrong with them on this side. So we can get the thermal camera. I have another one coming to review, by the way. This one a subscriber sent me to let me use it. I have another one with a larger screen that I should be able to attach to the computer that should make it easier for videos. But let's have a look. So switch on. And we can see it's just starting to warm up. And you can see these resistors here, yeah? 1, 2. Are warming up. Let's have a look at the other channel. And again, you can see there some resistors warming up. Yeah, they're getting warmer now. But I mean, they are 5-watt resistors, so you can assume they're meant to warm up. There's a couple other devices down there that are warming up. You can see, yeah. This one. It looks the same. It looks the same. Let's measure some voltages. So we have the voltmeter on volts. We'll reference all the voltages to ground. And the easiest place to find that is on the power connectors back here. The middle pin, that's ground. So we can stick that in there and we should be able to see we have a high voltage positive here, 100 volts, and we have a high voltage negative here, 100 volts near enough. Is that what's on these resistors on one end? Yeah, that's the 100 minus, that's 100 plus. So what's on this end? Yeah, 15 volts. That's dropping a lot of voltage. And it looks okay. 15.45. We go on this channel as well. We can have a look. 15.19. 15.5. So those are basically, within reason, very similar to each other. I don't think there's a problem there. Let's have a look then. We'll put some music on and let's have a look at the outputs from these two op amps and see if that tells us anything. Okay guys, so I'm kind of like sort of nosing around, if you know what I mean. For the data sheet on these op amps, there's two outputs. There's pin 1 and pin 7. But if there's anything on them, it's a very small waveform. Just turn the sensitivity up. Yeah, we have something on that one. Let's just adjust the sensitivity a little bit more. Yeah. So you can see that one. And if we look on the other channel, it looks basically the same, yeah. I can't see any real difference there, but see, we may have to try with the sine wave generator. Now, I can see there are some transistors here up the side, they bolted to the heatsink. So you think these probably be the driver transistors. Now, I'll just turn the bad channel off. I'm on the good channel, and I can see there's some resistors here as well, 100 ohm resistors, which are probably connected around these transistors. This is 2SA1837, this one 2SC4793. So I know a 2SA and a 2SC, one's going to be NPN and one's going to be PNP. It's complementary. That's just a bit of knowledge myself. So let's have a look. So we're on the end of the resistor here. This is the good channel. We can see a nice waveform. I'll just adjust it to the centre. Okay. And that looks okay. And then this is the other 100 ohm resistor. And that has a waveform. And that has a waveform. And they look kind of clean. Now, let's turn that down. This is the bad channel. I don't know if you can see it. I'll probably have to put a sine wave on, but I don't know if you can see on this one, there's like flat sections in the waveform. I'm not sure how well that's coming out. It doesn't look symmetrical somehow. You see how there's like more to the bottom than the top from the centre point? Okay, this one. See how it's kind of centred on the centre point of the screen? Yeah? And back onto the bad one again. Find the same resistor. It's kind of like too much at the bottom side. That's the only way I can really describe it. And I think it's more noticeable on this one. Yeah, can you see it now? Too much towards the bottom end. So, if you ask me, there's something wrong around here. Let's turn the audio down and let's measure some voltages in this area. We have a number of transistors. These are the ones where I can see the various waveforms. What's on the resistors? Well, that's minus 0.9. This one 0.47. 002. 0.3. So we're seeing definite differences in the voltages here. That's like the voltage I saw on the output offset on one channel. So on this one 0.374, 374 minus again. This is positive. Yeah, so we're seeing like a voltage difference across this resistor, for example, which tells me it's passing some current a little bit. There's a voltage drop. But this one is the same, like it's passing no current. Yeah, 0.374, 0.374. So you can say that isn't passing any current. This one is passing a bit of current. And from the value of the resistor in Ohm's law, we could work out how much. The other one, that's 0.026. That's passing a bit of current. What about this one? 0.30375. That's passing more current. So there's something not right around here. Let's look at the voltages on the transistors. So we have, I'm trying to think which way round it would be. This would be the base. 0.374 minus. That's the 100 volts. And this would be the emitter. 0.15 minus. So this transistor, emitter is minus 1. Was that the base? You know, guys, I've got it the wrong way round. I think this is the base, minus 1.5. minus 0.3. So this transistor is actually quite turned on. 1.5 volts, 0.3. That's like about 1.2 volts across the base emitter if it's switched on. That's wrong. This one, 1.5. Now that one, you see, minus 0.9, minus 1.5. So that's about 0.6 of a volt. And this has got 100 on the minus 100. Let's compare with this channel, the similarity. So we think this is probably the base, positive 0.8, 0.25. So that 0.82, 83, 25, just about switched off. 100 volt plus. And on this side, 1 volts minus, 0.4 volts minus. So again, there's about 0.5 of a volt difference. Yeah, and this would be the minus 100. So these transistors effectively just biased, so they're just about on, just about off. This is all screwy, it's not right. There's a couple of variable resistors here, and I'm wondering, for starters, if there's something wrong with one of these. So what I'll do is, I'll switch it off, and we can measure the resistance from each end of the variable resistor to the center pin on both to see how they set one compared to the other. Now obviously these are being used to balance the output. There's some capacitors around here that may or may not be involved with the problem, but it's looking like this here is all biased completely wrong, which is kind of explain why we had a distorted waveform where it was going much more to the negative than it was the positive from the center point on the oscilloscope. I'm very interested in this one with the 1.2 volts across the base emitter. I'm going to probably end up taking that one out and checking it actually. Or at least make sure I know which is the base and which is the emitter. Yeah, these resistors then. So we'll go into resistance range. And we'll just measure across the track. This is the value. It says it's a 1K variable resistor, 102. So we'd expect this to read. It's actually reading 200. Oh no, it says 201 on it. Okay, Captain Chaos and the camera strikes again. So it says 201 on it actually, so it's a 200 ohm resistor, okay? And then from this end to the wiper is reading 88. Yeah, 102. So we know the wiper's making contact to both ends because the two readings add up basically to 200. Yeah, 113, 88, and across the whole thing is about 200. So that's a good one. We know how it's set. How's this one reading? Well, it's reading 950. It's marked as, I can't quite read it. It's marked 302, which is like a 3K. It's a very strange value. Let's have a look at it. Well, it reads about 1K in circuit. How is it reading to the slider? Well, that reads like pretty much all the way over one end. Yeah, and that reads about 1K. So that's kind of adjusted all the way to one end. How's this one? It looks like it's probably the same physically. Yeah, all the way to one end. Yeah, and this one, so this is a good channel. 206, yeah. About 111. 97. You wouldn't expect them to both read the same because they will be adjusted, yeah. So it's not strange that it would read a little bit different. This transistor's got me wondering, the one with the very strange voltage across the base emitter. Let's have a look at what transistor it is and then double check again to see what the bias is on this transistor. Here is the transistor. It's a C4793, which will be a 2SC4793, I would think. I mean, we can have a quick look at the others down here, but I didn't really check the voltages on these at all. Yeah, those are 2SA. I'm not sure what this one is, but this is the one that seemed a bit strange. So this will be the base almost certainly. I'm going to look this up to be sure. And it was reading, if it's a PMP, it had a lot of forward bias, like too much in fact. Okay, let's find the datasheet for this transistor. Okay, it is in fact a NPN transistor. And base is the first pin. But I've also actually noticed now it is actually marked on the PCB anyway what these are. So I'll put it back on now, and I think we'll check all the transistors in this area to see how they are biased. Okay, so that's an NPN transistor. I've zoomed down a bit now so you can see one channel. You can probably see that's a B and that's an E. So the base collector emitter, all of them, yeah. We have 4 transistors down here and 3 up here, power transistors, and we have a number of others. I also measured to see where the slider of this goes to. And it goes to this transistor. And we see it's 0.612. So I'll just make a note of that as well. 0.612. And I can also make the same measurements on the other channel. Unfortunately, you can't see me do it, but it's the same point. And that's 0.814. And I'll put that on my list as well again. So I can just show you how I'm doing it. I've drawn out effectively the transistors. The numbers in brackets, and these are in volts, is the good channel, okay? Now let's have a look down our transistors and see what we have. And then we'll get the data sheets and see if they're NPN or PMP and see if we make any sense out of this. Yeah, minus 100. And the last one is the emitter. Minus 0.499. So there's definitely quite a few differences between our two channels. The most major difference is this. On this pin here, the base doesn't crackle, nothing happens, yeah. And the collector is reading minus 99. On the good channel, it crackles, reads minus 96, and the collector is 77. Okay, let's see if we make some sense out of what we've got. Now let's try to make some sense out of what we've got. I kind of messed this up, so I redrew this. So on this side of the amplifier, this is an NPN transistor. Let's just work out if it is biased on or off. So here we have the base is more negative than the emitter. It's negative by about 1.2 volts. So this transistor is off. It was NPN and the base is more negative than the emitter. So we have a high voltage across the base emitter. You'd expect that if the transistor is switched off. On the good channel, the base is almost 0.6 volts positive with respect to the emitter. It's about 0.583 of a volt, and it has the same 100 volts on here. So this transistor also appears to be off, or it has a high voltage across it, but the base emitter tells me it is on, or almost on. It's kind of on the cusp of being on. Because there's a high voltage across here, it probably isn't on. It's probably just biased, so it's almost on. This transistor is an NPN, and we can see that the base and the emitter are both the same voltage. So this transistor is off. Well, that one's off. On the good channel, I have to say the readings are a little bit strange. I mean, the base is 0.02. The emitter is minus 1.08, which suggests it's got more base emitter voltage than it could possibly have. And yet, that's the good channel. I'll just double check those readings. I might have made a mistake there. Let me have a quick look. Let's look at these other ones. So this one is 99.6. The base is less. It's a PMP transistor. the bass is less by about 0.6. Yeah, so this one is on the good channel, and on the bad channel, well, yeah, I mean the bass is a bit less negative, but not quite so much, so it's kind of not quite on. Yeah, it would have to be about 99.4 to be on, so that's probably off. And this one, good channel, again we can see the bass is negative by almost 0.6, so it's just on the cusp of being on. And this one is definitely off. Yeah, if that is a 6, I think it is, this one is off. Again, we should double check that one, because if that's 99.05, we have too much voltage across the bass emitter. Let's have a look at that one. So that's this one down here. You can see the meter there. It says, okay, so that's this one. Emitter 100, bass, yeah, 99.86. That's off. That's off. Okay, that's off. On the good channel, it's almost biased on, which you'd expect these transistors to be almost biased on. You'd expect that. This is where it had some very interesting readings. This is the other side. So we have these two transistors, and on the bad channel, if you touch the base of this one, it makes a click, but this one doesn't. On the good channel, if you touch the base of either, it makes a click. Okay, through the speaker. So let's have a look. Bad channel, base 99.34, emitter 99.91. Base is less than the emitter. This is off. Good channel, base minus 97.52, yeah, which is higher than the emitter by about 0.7 volts. This is on. Yeah, there's definitely a big difference there. We can see there. This one, base minus 99.4, emitter minus 99.8, so the base is below the emitter. This is off, it's an MPN. And on the good channel, base 96.86, which is higher than the emitter. Yeah, so this one is biased on. So we can see there's some problems going on with this amplifier in this area. Last one. This is a PMP. The base is more negative than the emitter by about 0.6. This transistor is on the good channel, and on the bad channel, well, we can see the base is -1, is more negative. Again, this one is biased on, kind of. This is 0.5, 108, 0.58. That's almost biased on. Almost, yeah. So that's what we have. Something wrong in this area. I think the first thing we should do is probably check all the transistors, but I think the transistors are probably okay. I might actually try measuring some of the resistances in this area as if I can find an open circuit track or a resistor, because it's looking to me something like that, or there's some problem with this biasing network. I've checked all the transistors in circuit using the diode test mode, and I've done the same on the good and the bad channel. They basically seem to be the same to me. I can't see any difference. I've tested all the diodes, all the semiconductor junctions. I've measured across all the resistors and the capacitors, apart from these electrolytics I can't easily get to, and I don't see any difference. All the resistances everywhere basically read the same. I'm pretty sure the op amp's working because the output waveform on both op amps looks the same. The only thing I can actually find any difference, but it's not particularly unusual, is on the setting of this pot. So if we look at the bad channel and we go from the top end of the pot to the middle, we actually read about 113. And if I go onto the good channel and read across the same 2 points, I read about 97. Yeah, 97, 113. Now this will be adjusted to balance this particular channel of the amplifier, but as I can't find any difference anywhere, I think I'll try and set this to the same as this one. Power it up with the current limiter and circuit, the light bulb, just in case. And if it powers up all right, I'll just try it and see whether by setting these to the same I can get rid of the distortion or make it worse or better. So let's go across here. I'll just find a small tool to adjust it with, a screwdriver or something else I can just get into there. See what I have in my little box of bits. Okay, it's easier once you don't have the camera on for some reason. So I've got it very close now. It's not exactly, but it's very close. So we have 96.3 on this one, 97.3 on that one. Let's power this up. We'll put the current limiter in, as I said, and let's see if there isn't a problem, whether or not the distortion's now gone away. I've put the camera onto the light bulb. You can see what it's doing here. So we're on limit. Yes, I'm going to switch this on. And it did the same as before, bright and then goes dim. So that's fine. We'll power the amplifier up. We're now on. And let's see what we have. So this is the channel that was good. And this is the channel that was bad. No, and that didn't help either. So now I think I need to find the instruction manual. Let's see if we can get to the bottom of this, because basically, although there's differences in the voltages, I can't see what's wrong with it. So I've used with it powered off, I've measured all the resistors and circuits, used diode test around the transistor. I don't really see any difference. I've not checked these capacitors. I'll probably have to dismantle it to get to those, and there might be a problem down there. And I've tried to find a schematic for this. I can't find a schematic, but I think we can probably work out what's wrong with it by starting from where the audio comes in and working back until we see where the distortion is. Now, to do this, we're not going to easily do it with music playing. So I had a look just from Google, really. I just Googled for audio frequency sine generator, and I found an online one that you just click on and it generates you a tone. So I'll show you what I found, and then let's have a look to see what's happening if we can figure it out. So the website I found was this one. So you literally just dial in your frequency. I've put 1000 hertz, and you click play. Once you choose sine wave play, and it just creates it for you. It just plays it for you. So that's coming through my mixer and to the input on the amplifier. Now the first thing we can see at the front of the amplifier is an op amp chip. I'll just show it to you in a minute, but this is the data sheet. So we can see that we have a dual op amp. We have an output on pin 7 and an output on pin 1, and we should be able to see the audio here. So let's have a look on ours now with the generator running. Let's see what we actually get. So I've started the audio playing, and we can just go to the input, and you can see something there. If I just alter the sensitivity, there's a sine wave coming in 1 kilohertz. Bad channel, good channel. Just alter the trigger level slightly. So that it's got okay. So that is basically the same coming in on both channels. Now we've got the op amp here, so we have output on pin 1. We have something there. 2, that's a bit nasty. We have an output on pin 7. Okay, I bet it looks the same on this one. I said it was a bit nasty. Yeah, that looks the same. That was the same. So output on pin 7, and we have a nice sine wave. And we just look at it. and it's basically the same on both channels. Yeah. Now we know the output goes to the main transistors, which are up here. I'm sorry, for some reason my camera goes blurred to one edge of the picture, but let's have a look. So there's something on the emitter. Let's see where it's going. I'll just set it to AC. Turn the sensitivity down a little bit. Let's see what we have. Well, that's on the base. Yeah, a bit less sensitivity. So we have a nice big sine wave on the base of the output transistors. Let's look at these ones. And we have something horrible. So somewhere in between on this channel is where it's going wrong. Let's have a look around these driver transistors, see what we can see. I'll look on the good channel first. Base. I'll probably have to set it to AC. It's going up off the edge of the screen. Let's have a quick look. Nothing there. And there's a sine wave on that one. Okay. And what's on the other side? Some more up here. Yeah, so we have a signal here. So look on the negative side, if you like. We have a signal there. Let's look on the bad one. So the same place. So we're on the base of this one. Base of this one. Okay, let's have a look at this one. So base of this one. And it's low and it's not nice. It's that horrible waveform we had again. Just try it again. Try the adjuster, we'll have a little bit. Yeah, you can see it there. Yeah, that thing. So that's what we have there. And on the base of this one, basically the same. And on the good channel, it's nice. And it's nice. So we now know the fault is between the op amp and those transistors. It might come through these ones. You see these two small ones. Let's have a quick look. See if we see a signal here. Yeah, there's a nasty looking signal. What's on this one? Yeah, let's look at this one. It's good. It's good, yeah. I need to figure out now how this transistor and this one connect to this op amp. It's in between. And there's some more transistors down here. So let's have a quick look at these to see if we can see anything down here. Okay, I had a look at the data sheet. So these transistors are all the same type. 2N5101. No, 2N5401, sorry. So let's have a look. So they go emitter base collector. So the middle pin is the base. And we have see like a distorted waveform on that one. Let's go on the good channel. We see a nice sine wave on that one. So that's the base. Next one. We see a nice sine wave on the base again. This one, we have this ripple on the power rail. Well, I'm on 10 millivolts per division. And we have a sine wave on the collector. Go this one. Sine wave? No, it's distorted. That's on the base. That one does have a sine wave on the base. I'm guessing that's the signal coming in to this circuit, which is okay. Although I can't, I've tried metering between there and pin 7. I'm not quite sure exactly how it gets there. This is the base of this one, which basically has like the same sort of thing on that one. And then on the collector, it's distorted. Whereas this collector is good. So it looks like the signal probably comes in here on the middle one from here somehow. So what I'm going to do is switch it off. I'll have a quick look to see if I can see how it gets from the base of there to pin 7 of here. But otherwise I'll take the amplifier apart. I'll check all these 3 transistors out of circuit, and while I'm at it I'll also remove these 2 and these 4 capacitors and test the capacitors as well, and may well replace them. So what I want to know is how we get from pin 7 here to base of here, and I can't easily see. It's probably a double-sided board. It looks like I have a connection coming from here, possibly down here somewhere. I'll just put the meter where you can see it. I'm using that one today. No particular reason, by the way. I'll put it onto continuity rate, see if that helps us. Okay, meter's working. Is that one there? We're actually on diode mode. I'm reading a diode junction actually there. Let me put it out of diode range into continuity range. That'd be better. I won't get so many false. Right, so the base of that transistor goes to a funny looking little, I doubt it's a, it could be a resistor, it's a funny looking little component down here. Let's look on the good channel for the same component. Yeah, it reads open circuit on both. Let me just go to ohms. Yeah, it reads like a 32k resistor. Reads about the same. And does that go? No, that goes to a power rail on here, I think. So I can't easily see how that signal gets back into here. It looks like it goes through this capacitor maybe. So I'll go back to my original plan, which is to dismantle the amplifier board. We'll check these transistors and check these capacitors. Okay, so to do this, I'm going to have to remove all these screws, both sides, to get the PCB off. Now I should be able to test the PCB on its own while it's not on the heatsink with a bit of luck if I need to. It looks like the main output devices, of which there are 5 at each side, if you like, positive half and negative half, all have insulating mica washers, so I need to make sure they go back. And it looks like these small devices, 3 here and 4 here, don't have. So hopefully there'll just be these ones to remember when I put it back together. I'm thinking the extra transistor on this side, which is this tip 122, might be acting as a voltage regulator, because there's only one per module. It's not part of the audio path, I don't think. Okay, I took the PCB off and now I can see what the problem is, or at least one problem. These, I redid this a bit tidier, but this is where I seem to have a problem around this transistor. So on the good channel, these are the voltages I see, yeah? And on the bad channel are these. You can see the collector voltage is completely different. The good channel is plus 77 and the bad one is minus 99, yeah? And also on these two, this transistor, if I touch the base with the end of my meter probe, and also on that one, these two, I get a click. But on the bad one, I only get a click if I touch this one. I don't get a click if I touch that one. Yeah, so this where the problem did seem to be, but the in circuit, the diode test tells me they're the same as each other. I can't see any difference between the two channels. So that's what I have, yeah. The good channel, and if we just get the meter where we can see it, okay. We have a connection from the collector. This is where we have the big difference in voltage from the collector. There's a track that goes down under here and goes to this resistor. Okay. That then goes, I'm guessing, to a power rail somewhere. It's a 4.7k resistor. On the bad one, can you see it? Do you see it, guys? So this is the collector that has a completely different voltage on, and I have a connection to there, but nothing to the resistor because the track's blown. So what I'm going to do is I'm going to take this transistor out and test it, although I suspect it's probably okay. And I'm going to repair this broken track. The 4.7k resistor will probably be okay because it's quite a high value, 4.7k. 4.7k. So that's what I'm going to do. I'm going to fix that track, which will probably just bridge from here to there, and we'll just give this transistor a test. And then let's see if we can actually get anywhere with this repair now. I have the transistor out. I didn't see any problems in circuit in this area, so let's have a look. And where that blown track is quite a high value resistor, so I'll be a bit surprised. Yeah, I'd be surprised if there was a problem with the transistor. It's good. Yeah. So we'll put this back in and we'll repair that broken track, and then let's try it and see if it now works. Okay, I've put it back together again. When you've had the heatsink off these, it's always worth making sure you don't have a short between the collectors of any of the transistors and the metal. I mean, the bolts effectively go straight way through, so if we just go on to continuity where you can see it and hear it, yeah, but it shouldn't go to the collectors of any of the transistors. That's the middle pin or this little tab. No, we shouldn't have anything to any of these. Okay. And obviously it goes to the screws. Yeah. And the same on the other side, of course. And then when you do power it up, always put the light bulb current limiter back in just to be sure. So again, we go onto the screws, just get a good connection. Meter leads fell out while I moved it, 1 moment. Okay, and then we just make sure we don't have any short to any of the collectors. Yeah, they're okay. I've connected it back up again. I've tried it with the current limiter, it seemed okay, so I switched the current limiter off. We're now just on normal mains. Now then, let's just have a look, see if we have an audio signal. I'll probably have to turn the sensitivity up on the scope. I can probably just select on here, 1 times range. Let's have a look. Yeah, and there we have the, oops, there we have the oscilloscope almost fell over. The earth moved, yeah. So there we have the good channel, we have an input signal. Bad channel, we have an audio input signal. So let's just go to these are the base resistors, these orange 3.3 ohm. So this is a good channel. I'll have to just, in fact, I'll set it to 10 times on the probe, see if that does it. Yeah, we still have a very big waveform. Let's turn the sensitivity down a bit on the scope. So there is one, that's the good channel on the output, yeah. On the output. Now let's look at our bad channel. And it's now got a nice sine wave, so it's no longer distorting. So it looks like that's probably working. I'll connect the speakers and some audio and let's see what we get. Put the mixer on. Aha. Ah. That was the bad channel. That was the good channel. Both now good, yeah? So, okay. As you can see, guys, that's now definitely working. So, another one fixed, yeah! After about a bit of that, yeah? Okay. So guys, I don't know how common this sort of fault is, but that's 2 power amplifiers in a row. Okay, one was a powered mixer, but the same sort of thing, yeah. That's 2 power amplifiers in a row with tracks with gaps blown in them, but the transistor that's connected to either isn't faulty, in which this case I can't find any faulty components on the thing, it's working, or it's being fed through a high value resistor where you think, well, not much current could go down that anyway. So what's causing this sort of problem? I don't know, but the third time I see one, it's not going to take me so long to fix, I don't think. I probably, with this one, went a very long way round to get to the fault. But you've got to remember, guys, with this sort of game, when you've got no schematic, something to fix, it's not particularly about how quick you get there. I mean, yeah, you might just get lucky or you might just spot it. But in the end, it's about getting there, yeah? It's about getting there. It's not really about the journey you took to it. It's the destination. And that that is a result. Yeah, that was a result. Okay guys, I know you'd love to get into them comments below, so here's your time. Sorry this video took a while, but hey, we did some work. Yeah, the speaker is going to cost them a lot of money to fix that. I can only assume, although it wasn't connected up this way round when I got to it, I can only assume that the blown speaker was on the bad channel originally, and then at some point they switched them around to put the good speaker on the bad channel for whatever reason, I don't know. So they want it back. We get some music around the pool bar. The speakers are in fact outdoor resistant speakers. Those woofers, 12-inch woofers, are like, first of all, they discontinued. Secondly, some people have got them, the Electro Voice ones, but they're like 350 to 400 euros. I've quoted them 400 euros to fix it, assuming A, I can even get one from a few people who seem to have them, and B, I can get it shipped to here, and it might cost more with the shipping. But what can you replace it with? You can't replace that with anything but an outdoor resistant speaker, because these speakers are used outdoors, a swimming pool and an hotel, yeah? So, another one, comments below. Anybody know what else I can replace that speaker with? I know some of you guys are much more expert than me. Some of you probably been shouting out over this one because you're much more expert than me. Yeah, I'm not an amplifier repair expert, but I think I've proved again on video I can fix them. Okay, love to hear from you soon. Love to hear what we can do with the speaker. Love to hear why this thing packed up in the first place, and I'd love to see you all on another electronics repair video very soon. Yeah, okay guys, ciao for now.